Hi guys, this is Suchi and in the today's video, I am going to discuss about the join operation in ND array. So how we can join multiple ND arrays into a single array. So for doing that, the first thing that we will do is we will import the NumPy package and give it a short name, which is NP here. So if I execute this line, import NumPy as NP, we will be able to access all the methods and classes defined under this NumPy package with the help of this short name. So let's get into an example. There are two ways to join multiple arrays into a single array in NumPy. First method is concatenate method. So let's look into this example. We are having two arrays over here. First one is array 1 and second one is ARR2, these two arrays. So let us just have a look into these two arrays first before doing anything. So here we can see this is array 1, which is having a shape 4, and there is the size of this array is 4, dimension is 1. So this is a single dimensional array having 4 elements. And ARR2 is another array which is having 3 elements, so that the size is 3 and the number of dimensions is 1. So these two are one-dimensional arrays and we are concatenating them into a single array. And the method that we will use is np.concatenate. So concatenate method in the NumPy package, we are going to use it. So np.concatenate, and then inside that, we are passing a tuple of arrays. So this is a tuple. If you see, this is a tuple that we are passing inside this concatenate method. Okay. So we can have more than 2 also, because this is a tuple format. And if we look at the result, what we are doing, we are concatenating ARR1 and ARR2 into ARR. So ARR is our final result. So let us see what happens if we execute this. So here you can see this is the first array, which is having a size 4, dimension 1. This is the second array where size is 3 and dimension is 1. Again, the result is a single dimensional array. Here you can see the result's dimension is again 1. And the size is 7, which is 4 plus 3, 7. And both the arrays are concatenated along the 0th axis. Here you can see 1, 2, 3, 4 and then 5, 6, 7. Because this is one-dimensional array and we are having only axis 0. Now, if we want to specify the axis number, there is definitely one parameter to this concatenate function, which is axis parameter. So let's look into this code where we are actually specifying the axis value here. So by default, if we do not specify the axis parameters value, it will be taking as 0. That is why we are seeing here the result is concatenated along the 0th axis. Here, if we run this code, it will return the same result because we are specifying the axis 0. Here we didn't specify the axis, so it was by default taking axis as 0. So if I execute this one, here you can see the result remains same. This is the result. This was the result in the previous stage also, where we did not specify the axis. And if we specify the axis, again, it is giving us the same result. Now, what if we want to specify the axis as 1 in this case? So as you can see, these are one-dimensional arrays, which we are concatenating. So there is no existence of axis 1. Only axis 0 is existing because this is the one-dimensional array. So only one axis should be present. But if what happens if I specify 1 here and execute this? What do you think? So let's have a look into the result. Here we go. So what we are getting? We are getting an access error. What it is saying? Access 1 is out of bounds for array of dimension 1. So as our arrays are single dimensional array, so there is only access 0 present. If we say that concatenate these over the access 1, then it is going to throw us an access error. What? Why? Because this access number does not exist. It is out of bounds for one-dimensional array. So it is very clear. Now we are moving to two-dimensional array where we are having actually two axes, 0 and 1. And let's have a look into two-dimensional array. Now, here we are having two-dimensional arrays. ARR1, which is a two-dimensional array. Again, ARR2, that is also a two-dimensional array. And now, if we concatenate them without mentioning any axis, it will by default take axis 0. That means it will return an two-dimensional array where there will be 4 elements total. So let's have a look into the result. So here is our array 1. Shape is 2 by 2, 2, 2, and size is 4. Definitely because there are 4 elements, 1, 2, 3, 4. Dimension is 2. Again, this is the array number 2, where shape is 2, 2. Again, size is 4 and dimension is 2. Now, the result becomes again a two-dimensional array only. The dimension, so here you can clearly see while we are concatenating, the number of dimension of the arrays which we are concatenating will be the number of dimension of the result that we are getting. So here what we can see here is one array where the shape is 4, 2. Why? Because we have not mentioned any axis. So it is by default taking axis 0. That is why from the shape you can see the 0th element is being added. Here itself the concatenation is happening. So 2 plus 2 is becoming 4 over here. And this one remains same because we have done it over axis 0, not axis 1. And dimension remains same. Size becomes 4 plus 4, 8. And here you can see it has been concatenated over the 0th axis. Now, what if we want to concatenate over the axis 2? I mean axis 1. So if we want to do that, we can specify the axis as 1. And then let's execute it. So here you can see the result where the concatenation is happening based on axis 1. So this one is coming here and this one is coming here. So basically this part is nothing but this part here. And this part is coming here, right? This is what we can see while we do this along the axis 1. So this 1, 2 and this 2 is getting added to 4 here. And again size is getting added 4 plus 4, 8. Dimension remains same, 2, 2, 2. So that is how we can concatenate for even greater dimensions also. Now, if we want to get an result which is having a higher dimension, here we can see in concatenation, we are trying to concatenate this and this one, and we are getting the result in the same dimension. Similarly, here also, we are concatenating these two arrays and we are getting the resultant dimension as the same dimension. That sometimes we want to join two arrays, but we want these arrays to stack over each other. Stacking means what? One at the top of other. So if we want to stack them instead of just concatenating them, then there is another function that is stack. So we can use stack method from NumPy to achieve that. For example, here we are having two arrays, 1, 2, 3, 4, 5, 6. Now we want to stack them over each other. That means we want 1, 2, 3 as one element, 4, 5, 6 another element, and a two-dimensional array. So something like this, comma 4, 5, 6. So we want a result like this. So these will be stacked over each other. If we want that, what we can do, we can instead use stack. np.stack and then pass the tuple of arrays. And then let's see what the result is. So here you can see, this is a one-dimensional array, which is array 1. This is another one-dimensional array, array 2. Size is 3 for both of them. Now the result is 2, 3. That is having a 2-dimension. So the result is now not an one-dimensional array. It is a 2-dimensional array. And there are 2 elements, just like we wanted it to have. Similar thing, if we want to do it not along the 0th axis, here it is just stacking in the 0th axis. Now, if we want to stack it over the axis number 1. So basically, we want this to be stacked like this. So let me just show you what exactly we want. We want to have something like this. So this 1, 2, 3, which is coming from the first array, should be column wise distributed. Then this 4, 5, and 6, this should also be column wise distributed. This is what we want. So this 1, 2, 3 should be in the first column. This 4, 5, 6 should be in the second column. And it will be a 2-dimensional array. This should be our output if we want to stack them along the axis number 1. So that we can achieve with this axis parameter. So here you can see, we can also specify axis inside this stack function. So if we specify axis equal to 1, we will get the result that we are expecting here. So here you can see 1, 2, 3, 4, 5, 6. Right? We are getting 1, 4, 2, 5, 3, 6. 1, 4, 2, 5, 3, 6. So column wise, they are getting distributed. That is how we can use the stack function also to join two arrays. Now there are some specific functions which give some specific type of outputs. So here we can actually specify the axis and we can get our expected result. But there are 3 more stacks, which is hstack, vstack, and dstack. They actually returns a specific type of result. For example, hstack. Hstack will always horizontally stack the elements. For example, these 2 are there. So if we do a hstack here, it will horizontally stack the elements. That means it will again behave like a concatenate operation for 1D arrays. So if I just execute this, here you can see this is just horizontally stacking the elements. These three and these three, they are getting horizontally added to one another. So this is one way of doing it, hstack. If we look at, if we check with a two-dimensional array here, how it will work? It will again horizontally stack them. So if we just execute this, here you can see the elements are horizontally stacked. So this is placed, this is being placed here. So basically, this part is being placed here. Okay. That's how it is getting the, it is showing the output. So this is nothing but horizontal stacking. Here we cannot specify any axis or something because this parameter does not exist here. So if we specify this one, it will say that there is no argument. So it is saying got an unexpected keyword argument axis, because we cannot specify any axis here with hstack because it is by default taking for vstack also. If we try to specify that kind of parameter, it is not going to happen because hstack itself says that it is horizontal stacking. So axis is not required here. It will be by default doing it along the axis 1. Now, if we use vstack, vstack is again going to do what? Vstack is going to do a vertical stacking. Sorry, hstack is going to do it along the axis 0, basically, because horizontal axis. Vstack is the vertical axis, that is axis 1. So it is going to stack over the vertical axis always. We cannot specify any axis because axis is already specified, because it is a special type of function which is going to do it vertically only. So if we just do it here, vstack with the vstack for one-dimensional array, it is going to give us the exact result that normal stack gives us. So here you can see this is doing along the 0th axis. I mean, this is doing along the axis 1, which is a vertical axis. And dimension is becoming 2. Now, if we see the same thing for two-dimensional array, we can see there also it will do along the vertical axis itself. So let's execute it. Here you can see it is having 4 elements. Along the vertical axis, it is stacking this over this. So this is how vstack and hstack works. There is another stacking, that is dstack, and I will suggest to play around with dstack to understand it better. Here I am showing you with an example. So if we apply dstack on two one-dimensional arrays, the result you can see here is, here you can see 1, 2, 3 are along this, 4, 5, 6 are along this. So this is, again, this is returning a 3-dimensional array instead of returning any 2-dimensional or 1-dimensional array, which is depth-wise stacking is performing. Now here also we cannot actually specify some parameter like this, because this by default means that this will do depth-wise stacking. We can check this dstack for a 2-dimensional array also. So if we see for them how it is coming out. So here also you can see this is a 3-dimensional array which we are getting, and it is doing a depth-wise stacking. So for the first element of this array, it is stacking with the first element of the second array, then 2 with 6, then 3 with 7, 4 with 8, Like that, it is doing a depth-wise stacking. So that's it for today, guys. I hope you have enjoyed this video. In the next video, we will talk about more on ndarrays. Till then, keep learning, keep implementing. Thank you for watching.